Hello, welcome you all in Data Insight with Deepankar. Today we are going to discuss about one of the most important topic that has been asked either you are beginner, intermediate or a experienced folk, and that is performance tuning and query optimization. So first of all, we have to understand what does this term means, performance tuning and query optimization. So here we will take a general example like you are using PhonePe, Paytm or any other banking application and you want to just fetch up your balance details. So what you will do, you will just enter your PIN and you can see the balance details. The process will be done in a minutes. But what will happen, this process will take more than 5 minutes or 10 minutes. You will say the banking application, it is not working properly. But what is happening internally? Internally, when we will just try to fetch up your balance detail, the query is running internally. When query is optimized, it will give you output in minimum amount of time. The time complexity will be low. But when the query is not optimized, it will take more time. So this is the important topic because it is very helpful in a production level and it is very helpful for interviews. So there are various parameters to improve performance tuning and query optimization. So here today we are going to discuss about that. First point is indexing. What is indexing? So we will try to understand this concept by a day-to-day example. Just take example of a house. Like in morning, if we have to search for something like a key and we haven't kept it in a particular place, we have kept it anywhere. So it will take more time to find out. But in another scenario, just take an example of a medical shop where they have tons of inventories, but when we ask for a medicine, they will just go and find out. Why? Because they've sorted the data in a good manner. Therefore, they are giving us the medicine in lesser time in comparison to your home where we haven't kept a key in a proper place. So this is a general example of indexing. Now we are taking another example. Just take an array which is having values of 3, 5, 8, 9, 7, 10 and 0. And here we have to find out the value of 0. So how much time it will take? First of all, it will go to the first position, second, third, fourth and so on. The time complexity it will take, it is big of n. But how can we improve this? If we can sort this array in such a manner like 0, 3, 5, 7, 8, 9 and 10. Now we will find the value of 0. So it will find in a first go because the array is in sorted manner. What will the complexity for this? It will be big of log n. So this is a general example of indexing. So how can we define indexing? It is nothing but a technique to apply binary search in a table, just like we did above. Now here we will take one more example so you will have more clarity. Here we have a stock exchange table where we are having two columns, name is name and amount. We have name like Roy, Monu, Sonu and Golu and their respective amounts. If we have to find the amount of Golu is 1800, we will just write select star from table name where name equals to Golu and we will get output in this instant. But in production, we are not having 4 records. We are going to have millions of records. So it will take more time. Here indexing comes into the picture. How can we resolve this issue? So what we have to do, we have to create an indexing column for amount. Now with the help of indexing, what it will do, it will rearrange the data of amount column in a sorted manner. So we will have 1200, 1800, 4000 and 10,000. Now if we'll search for the amount of Golu, which is 1800, we will get in second position. Why? Because it is sorted. So in short, we can say that in first case, when the table is not having indexing column like amount, it is taking the time complexity of big of n. But when we have sorted this data, and here the 1200 is pointing to this 1200, 1800 is pointing to this 1800. So just it is created a lookup table, and it is navigating to its native table with the help of pointers, like 4000 to this 4000 and 10,000 to this 10,000. So now with the help of indexing, the complexity become to big O of log n. So this is how indexing works in backend. So if we have to define this term, it creates a lookup with a native column, just like here it is created for mount, and the pointer to the memory location of the entire row or each row. So if we go for an interview, what interview will ask? What is syntax of indexing? The syntax will be create index, the index name on table name. Like here we apply for the mount column. How will you optimize? So here we have explained the entire optimization process, what is happening internally. Which data structure indexing use? It is a B tree. What is B tree? So here I have tried to create table in Sublime. So here we have 100, 1 to 50, 51 to 90, and if we have to find 90, if we go with a normal approach, then it will take complexity of big of n. But with the help of B tree, first of all it will go to this node and it will go to right node, because 90 is present there, because 90 is in the 51 to 100 bracket, and we can find this value, and the complexity will improve. But we can't use indexing everywhere. There's some scenarios where we can use, and there's some where we can't. So if we have to do reading operation like select and all this stuff, we can use indexing. But when we have to do writing operation like insert and all of this stuff, we have to avoid this. But why? So just coming to this above table, this is stock exchange table. Here we have amount column, which is having of 10 millions of rows. And if we want to add 5 millions of rows, then what will happen? It will add 5 millions of row in this main table as well as in this lookup table also. So it will take more time and it will be more tedious for us. So we have to use indexing selectively only for reading operation. I hope so you understand the concept of indexing. If you have any doubts, just drop a comment. If you want a separate video to understand the concept of indexing with the help of animation, I'll try to do this, but you have to just drop a comment. Now coming to the another aspect of optimization, this is numeric field. Like when we create a table, we don't think about that which data type we have to use. Like we have to do for salary column, we are using varchar or some kind, but salary is just like a numeric value. We can go for int or float. This will definitely optimize the process. So just remember, when we are using numeric field, just try it for int and float. Third point is that we have to use nvarchar or varchar in place of char. But why? Because char is having a trailing spaces. The trailing spaces will acquire more, it will need more memory. So avoid char and use nvarchar or varchar. Fourth point. This is also an interview question. What is the difference between union and union all? So first of all, we try to understand the concept. In union, we will have a duplicate. In union, we will not have a duplicate records. It will eliminate that and it will sort that. So it is also a process. So it is a process, it will take more time. But when we're coming to union all, it will have a duplicate records. So it totally depends upon the use case. If you want duplicate records, then go for union all. But if you don't want, then go for union. Now coming for the fifth point. Just take an example of any big organization or a big product based company, and we have to just do a select star from table name, and we are having 10 millions of data. The SQL server is stuck because it will not able to showcase this all of this data. So for such scenarios, or for in general, just try to apply a where condition, because you only have to see the data for a particular entity or for a particular condition. So use select star from table name and condition. Now coming to the sixth point. As we know about the indexing is used for optimization. So avoid not equals to sign like this and this, because indexing works for equals to only, but not for not equals to. Seventh and last point is that don't use count, use exist. But why? When we use count, it will search for the entire data and give us the count. But when we will exist, it will go for that current point in which we are comparing and give the output. So it will take less time. So there are 7 points that we have discussed. There are some few more points we can also discuss about that. Hope so you understand all of this concept clearly. Please like, share and subscribe my YouTube channel. Thank you for watching. Have a great day ahead.